In this problem, we're going to solve the trigonometric equation, and we have 5 minus 7 sine of x, and we're looking for the x values where it will equal 2 times the cosine squared of x. Notice that I'm using the variable x, and that we're looking for answers between negative 2 pi and positive 2 pi. So right away, before I start this problem, I'm going to look at the graph. And so the 5 minus 7 sine of x is this larger purple one, where the cosine squared of x is this smaller blue sinusoid. We're looking for where they equal between negative 2 pi and positive 2 pi. And so I can see that I'm going to have a unique answer here and here. So there's two of my solutions. The other two are going to come from these two intersection points. So that gives me an idea that I'm going to have 4 total answers. So right away when I look at this problem, I notice that it looks somewhat like a quadratic. We did one in class like this where we're going to have to substitute this cosine squared in for its Pythagorean identity. And so I'm going to leave the left side the same. And I'm going to rewrite just the cosine squared as 1 minus sine squared using that Pythagorean identity. From here I'll have to distribute through this 2. So I will have 5 minus 7 sine of x equal to 2 minus 2 sine squared of x. So now it kind of resembles a quadratic equation. And so I'm going to rewrite everything to be to one side, and I want this sine x squared to be positive to make it easier to factor. So I'm going to add the 2 sine squared over. I'm going to then just bring down this negative sine of x. It will be unchanged. And when I subtract this 2 over from the 5, I'm going to end up getting a positive 3. And so now you can think of this quadratic equation as being similar to 2x squared minus 7x plus 3 equals 0. So if that helps you see this problem a little bit better, you can rewrite it to look a little bit different. And so I will end up with a 2x and an x to get 2x squared. And then I'll need a 3 and a 1. And I chose to put my 3 here, so this will give me 6x. And then this will give me 1x. Well, 6 plus 1 will give me 7, but I want a negative 7. So both will be negative. And so the solution from here you could set equal to 0. So x will need to equal 1/2. Here, x would need to equal 3. Now keep in mind that this isn't a quadratic equation, and instead of x's we have sine of x. And so I'm going to rewrite this factored form to sine x minus 1, sine x minus 3. Same idea, set each of them equal to 0, so I know I'm going to want the sine of x to equal 1/2 and the sine of x to equal 3. Now right away, I'm going to cross off this part of my equation because I know that sine can never be larger than 1. This would be like saying that the opposite side is 3 and the hypotenuse is 1. Hypotenuse always has to be the longest side, so this answer doesn't make sense. So from here, I know that I'm going to get all 4 of my answers by finding where sine is 1/2. And so I know that sine is positive in the first quadrant and in the second quadrant. Now, if you look to your unit circle, you'll find that sine will be 1/2 at pi over 6. But let's say you didn't think to look on your unit circle. As long as you're in radian mode, you could do sine inverse of 0.5. And you would get 0.5235, which is the same thing as pi divided by 6, just the approximate value. And so that's my first answer. You could write it as pi over 6, or you could write it as 0.524. And again, that's radians. That's an angle in radians. My other answer will be the one in the second quadrant. And so I know that this is pi over 6, which means this reference angle is pi over 6, but we're a little bit short of 1 full pi. And so to find this angle, I'm going to take pi minus pi over 6, or minus the 0.524, either way. So pi minus, I'll grab that number, and my other solution will be 2.618 radians. And to find more answers, I know that I would then have to add one full revolution, which since we're in radians would be increments of 2 pi n. Now, looking back at the domain where I'm wanting my answers, I want all answers between negative 2 pi and positive 2 pi. So that's roughly in between negative 6.28 and positive 6.28. And so both of these starting points that I've found here are going to be answers. So I'm going to go ahead and circle those so I know that we're halfway done as far as finding those 4 solutions. I'm going to now look back to the graph. And so the answers that we found is right here, the pi over 6. And then the other one that we found was the 5 pi over 6, but again we found that as an approximate answer. And so we found our circle and our square, our 2 unique solutions. So now I can see to find my others that I'm going to need to subtract 2 pi from both to get the others. So this is going to be 2 pi apart, and these two are going to be 2 pi apart. So again, looking at the graph helps us figure out what we need to do to get to our other answers. So now that I have the 0.524, I'm going to subtract 2 pi. And even though I'm rounding on my paper, you'll want to use the entire answer in your calculator, especially for typing answers into WebAssign. And I will get approximately negative 5.7, and that would round to 6. That's my third answer. And then my last one, I'm going to start with the 2.618, subtract 2 pi, and again, use the entire answer in your calculator. Also make sure that you're using the pi button and not 3.14, and we will get negative 3.665. Now that we've found all the solutions, we are done with this problem.